Okay, welcome back, guys. Page 4 now, starting with number 22. If I start getting a little delirious, guys, it's because I'm here working at 5:30, 6 o'clock at night trying to get these up here for you. Hope you guys appreciate it, and hope you guys do great on the test. I really do. So let's start with number 22. We've entered the circles realm here, and so we're going to find the circumference of this circle. Now remember, we talked about circumference parts and circumference wholes. This is only concerning with the circumference whole in this case, so there's no reason to set up a proportion. We're just going to use the circumference formula. So we know that the R is 5 centimeters. And we know that the formula for circumference, there's two of them. We could use 2 pi r, or C equals pi times d, where d is the diameter. Now I just pick whichever one I use based on what they give me. Since they gave me r here, there's no reason to use pi d. I'll go ahead and use 2 pi r. So I'm going to say C is equal to 2 pi times 5 centimeters. So this is 10 pi centimeters, which is approximately, well, this is 3.14, so 3.14 times 10, that's going to be 31.415. Oh, it said to the nearest hundredth, so 31.4242. Okay, and that is in centimeters. Okay, moving on to number 23. Okay, and we've got a sector. Now this is the case where we want to find the partial length. We're looking for this length around the circle AB right here. Okay, so this is that length that we're looking for, and that is a part of the whole length. So let's write down the things that we do know. Let's make our box over here. Okay, so we know our R is 6. We know our D. We don't really need to worry about D in this case, but sure, whatever. We do know that our degree, the partial degree around this, is 125 degrees. So I'm going to put that down, 125 degrees. What's the total degrees? Yeah, you guys probably sick of saying that, right? 360 around a full circle. So what's the partial circumference, which is the word arc length, right? This is the length of the arc, AB. Okay, so arc length is the partial circumference, and that is the unknown in this case. So we're going to come back, and I'm going to put that as use my pencil here. We don't know that. We want to know that. And then what is the total, the whole circumference? Okay, that's going to be 2 pi r's. We don't know what it is, but we can find it with 2 pi r's by plugging in 6 for r. And this is going to be 2 times pi times 6, which is 12 pi units. Okay, good. And so I think we've got enough. It does not seem to need us to do the area part and the area whole. So there's no reason to really set it up because it doesn't seem to need us to find those. So if I look at this, I just now need to go set up a proportion that involves CP that I can solve. So if I start with CP, and we said we just need to make sure that those proportions have matching properties here and here. So we've gotten pretty good at putting CP over CW equals D part over D whole. So this is C partial circumference over the whole circumference is partial degrees over whole degrees. And now plug in the pieces that you know and the pieces that you don't, and find the pieces that you don't. So we don't know CP, we'll leave that. We do know CW is 12 pi. And I'll put the units on here in a second. Units, I'm just going to use U. Partial degrees is 125 degrees and 360 degrees. Okay, so how do I solve this? Well, I'm going to multiply both sides by 12 pi u to get this CP alone. Okay, so I'm going to move this out here. And I'm going to end up with just CP on this side whenever these cancel. And this is going to end up over here on the top. I'm going to go ahead and cancel the degrees here. And I'm going to cancel the 12 into the 36. and that's going to leave me 1 here and 30 on bottom. Now, I also notice, hey, 5 goes into 30, and that's 6 times. 5 goes into 125. Well, 5 goes into 100 20 times, 5 goes into 24 times, and then 1 more. So it's 20 plus 4 plus 1, which is 25. So the partial circumference is equal to 25 divided by 6, and I still have the pi and the units out here, so that's pi units. And this is how I would prefer it, but in the test they might ask you to round that. Hmm. 25 divided by 6 times, whoop, I hit the wrong thing. 25 divided by 6 times shift pi, and they're going to give it 25 over 6 pi. Well, that's aggravating, but hit this S to D button down here, and it will give it to me as a decimal, 13.089. So it looks like to the nearest tenth that'd be 13.1 units, and we're good to go. Okay, on number 24, we're looking at find the radius of this circle C. And this does have a partial, so it looks like we're going to have to set up our box here. So the radius, oh, I need to go back up here and fill this in on the last one, guys. I had my question mark, and that's what I wanted to put in there, so I'm going to erase that question mark. And I'm going to do 13.1 units here. Okay, so let's go back to our box here. I've got R is the unknown. That is the thing I want to find. So I'm going to put in my question mark here. I do know a partial circumference, and therefore I'm going to probably need the whole circumference as well. And I know a partial degree partial, and I'm going to probably want the whole degrees. Those are pretty easy to come by. 360 is the whole degrees. The partial degrees is 75 degrees. The whole circumference is going to be 2 pi r, but we don't know what r is at this point, so let's just leave that. We'll try to figure that one out in a minute. And then the partial is going to be 35.5. And we don't know what that is, so we'll just call that units. So this is my data bank here, and I need to find the r. If I set up a proportion, it looks like the only thing that has to do with r is CW here. So if I start this by putting CW up in the top right corner, CW is 2. In this case, I'm going to do something a little different. I'm going to show you guys different ways to set up these proportions. As long as we match things up top to bottom and side to side, we'll be good. So if things match this way, you know what? DW, they are both wholes, so I can match those up. And then if I come over here, I can match, you know what about the partial circumference and the partial degrees? Okay, great. So now let's plug in things, and we're going to get 2 pi r over dw is 360 equals, and this would be CP, which is 35.5 units over partial degrees, which is 75 degrees. I'm going to go ahead and reduce a little bit here. So I got a 2 that we can reduce with the 360, and leaves me 180 degrees. And then, 35.5, man, that one's going to be a little bit more difficult to deal with. But, if we multiply both of these by 10, that would be one way to do it. And I'd end up getting 355 over 750. Okay. So I'm going to go ahead and move up here. And I've got pi r over 180 degrees equals 355 over 750 degrees, so that's units. And I'm going to multiply both sides by 180. and I'm going to divide both sides by pi. And that's going to allow these pi's to divide out and be 1, and allow these 180s to divide out and be 1, and only leave me an r over here. So now I just need to look for some things that I can reduce here quickly. So 180 and 750 both into 0. That means that they can be divided by 10. And let's see. I know that 3 goes into 75 and leaves me 25, and 3 goes into 18 leaves me 6. 5 appears to go into both of these, so that's going to be 5 goes into 355. I know that 5 goes into 35 7 times. So it'd have to go into 357d times, and that'd be 1 more. So I bet you that's going to be 71 times 5, and I'll leave a 5 on the bottom. Okay, so this is 71 times 6 over 5 pi. So 71 times 6, 7 times 6 is 42, so that's 420 plus 1 more 6 is 426 over 5 pi. And the degrees and the degrees over here cancel. I should have had a degree there. I don't know why. Carry that. And then I have units. So I can find what this is. R is approximately 426 over 5 pi. Oh, see, now I got to be careful, because I did not put a parentheses around this, and I ended up getting 426 over 5 times pi. But I want the pi on the bottom. So I better do this again. I'm going to use a parentheses this time. This is a built-in parentheses. So 400 and what was it? 426 divided by 5 pi. Okay, and that's going to be a difference. It's 27.12. And it said round it to the nearest tenth, so 27.1. Okay, and now I'm going to go ahead and plug that back in up here. It's 27.1 units. Okay, moving on to number 25. Okay, part is to whole, so once again I'm going to set this up. I don't know what my r is, and it looks like they want me to find circumference, so I may not even need to worry about r this time. I do know what my partial degrees are. They're 50. I do know what my whole degrees are. They are 360. I know what my partial circumference is. It's 9.2 units. And I don't know what the whole circumference is, but that is what they want me to find. So that's good. This is what I'm looking for right here. So I'm just going to set this up. This will actually be a little easier than the last one. CW over CP equals DW over DP. Notice the things line up. C's, D's, W's, P's. Okay, so now replace items. And I've got CW over 9.2 units equals DW, which is 360 over 50. Reducing the zeros here, multiply both sides by 9.2, and I'm going to get CW equals 36 times 9.2 over 5, and that's units. So CW is 36 times 9.2 divided by 5. I apologize, guys. I am running out of time. I need to get out of here, so I'm going to use my calculator a little more right now. And that is going to switch over to a decimal of 66.24. Okay, and there it is. Okay, now this is a definitely interesting problem here. So we're going to attack this first by noticing what the different pieces are. This 3y minus 5 is marked on the outside, and you notice it doesn't have a degree symbol, so I'm thinking it's probably a length. That probably means it's this length. And that length is called the partial circumference, or the arc length, if you will. R is 20. So my CP, my partial, is 3y minus 5 pi. My whole circumference we haven't got yet. And let's see, my partial degrees, my degrees partial, is 5x minus 15. Yeah, that's going to be weird. And my whole degrees, obviously, are 360 degrees. Okay. So maybe I need to find some way to set these up. So what do I notice about the degrees here? Well, they gave me the reflex angle. This is 220 degrees on the backward side of this. So that means that this 5x minus 15 and this 220 together, that's the sum of parts. They go together to add to be 360. So if I start that, I'm going to say, you know what? 5x minus 15 degrees plus 220 degrees equals 360 degrees. Now, luckily with units, I can divide degrees on all three of them and cancel those out, and I can get rid of those units. Putting these together, I'm going to get 5x minus 15 plus 220 is plus 205 equals 360 minus 205 from both sides. I get 5x equals, and that's 155, I believe. So divide by 5, and I'm going to get x equals 31. Okay, so there's my x, and that's one of the questions they asked us. And so now I might need to use that x to figure out what the partial degrees were. So if I plug that in, 5x, well, we know that's 155 minus 15. So 5x minus 15 equals 155 minus 15, which equals 140 degrees. Now that might have been easier got by saying, you know what, it's 360 minus 220, right? Okay, so my partial degrees is 140. And then how am I going to use that to figure out what my whole is? Well, I may not even need to, but we'll find out. I can find my whole here is 2 pi r. And so that's 2 times 20 times pi, so that's going to be 40 pi. So I can use this to set up a proportion now. And I can say, look, what I'm looking for is this y value, because that's the other thing I need to find. I need to find the y. And it's in the CP. So I'm going to put CP over CW equals DP over DW. So 3y minus 5, close parentheses, pi over 40 pi equals 140 over 360. Now luckily I got a lot of stuff that can cancel here. Or degrees over degrees. This pi is multiplied times this whole term, so pi over pi can cancel. I can cancel this here. These are both even, so that's going to be 7 and half of 36 is 18. Okay. I can multiply both sides by 40. Reduce those. And I'm going to get 3y minus 5 equals, and then I'm going to reduce once again. I get 20 on top here, 9 on bottom. So that's 7 times 20, which is 140. It's funny, it got back to right where I was. Over 9. Okay. So now I need to add 5 to both sides. So I get 3y equals 140 over 9 plus 5. And then finally I'm going to divide by 3. Now 5 in sheep's clothing is, I'm going to multiply by 9 over 9. That's 1 in sheep's clothing, right? And I'm going to end up getting 45. This is 45 over 9. So that's going to be 185 over 9. And that whole thing is going to be divided by 3, or multiplied by times 1/3. You can also times 1/3 here, right? 1/3. And so that's going to be 5 over 27. Okay, and 185 is not going to be divisible by 3 because 1 plus 8 is 9 plus 5 is 14, and 14 is not divisible by 3. That's a divisibility check for numbers divisible by 3. So this is as reduced as it gets, but I can put it in decimal format. 185 divided by 27 is 6.9. Now, I might have made a mistake in there somewhere. It's possible. I would have thought that would have come out a little bit prettier. Let's do this. 140 divided by 360 7 over 18, that was good, times 40. 140 over 9. I think I'm good here. So plus 5, 185 over 9, and divided by 3. 185 over 27. So I believe we're good. Okay, the final one for this page. Okay, find the radius. So I'm looking for r here. And it looks like I've got a partial area, right? This is a 95 degrees, and this is 47.5 centimeters squared area in here. So if I got r as the thing I'm looking for, I've got my degrees part, 95. My degrees whole is 360. My area part, well, that's what they gave me, 47.5 centimeters squared. And my area whole, well, that's unknown, but I do know it's pi r squared. So I'm going to go ahead and put this as a proportion here. And so I'm going to get, I'm going to put AW, because that has the R, and I'm going to put that at first. AW over AP equals DW over DP. So AW is pi r squared over AP is 47.5 centimeters squared equals DW, which is 360 over 95 degrees. Good, so degrees and degrees can cancel out. I'll go ahead and reduce 360 over 95. 5 goes into both of those. And that'll be 19 on the bottom, and 360 divided by 5 is going to be 72, and the degrees are gone. So multiply both sides by 47.5 and divide by pi. So I'm going to divide by pi and multiply by 47.5, divide by pi and multiply by 47.5 centimeters squared. These will cancel, and leave me r squared equals 72 times 47.5, and I'm going to go ahead and put that in my calculator, guys. I just don't have enough time here. 47.5 times 72 equals 3420 divided by 19 equals 180. Well, let me make sure that was right. I just want to make sure I didn't make a mistake. 72 times 47.5 divided by 19. And wow, look at that. It comes out to be 180, right? So all of these things are going to multiply together and divide, and you're going to end up getting 180 over pi centimeters squared. Okay, so now I need to take the square root of both sides because I have r squared and I want to get it alone. So I'm going to move up here, and I'm going to get r equals the square root. I don't have to worry about the negative side because this is a distance of 180 over pi. And when I take the square root of centimeters squared, that's going to cancel out and just leave me centimeters on the outside. So r equals the square root of 180 over pi, which, take the 9, that's 9 times 20. Take the 4 out, and then that's 6 roots of 5 over pi, and that's centimeters. And if I do that on here, I'm going to get square root of 180 divided by shift pi equals 7.56. And we'll call that centimeters. Okay, that's the end of that page.